Imagine a place where gravity is so intense that not even light can escape. We are about to embark on the ultimate one-way trip into the heart of a black hole. Join Nova as she faces the most terrifying thought experiment in the entire universe. But wait! If we were watching Nova from a safe distance, we would see something absolutely mind-bending. As she approaches the edge, she doesn't just fall in, she appears to slow down, freeze in place, and slowly fade into a deep, ghostly red. But for Nova, it's a completely different story. She looks at her wrist, and her watch is ticking away perfectly normally. But when she glances back, the entire universe is warping into a shrinking circle of light behind her. But the view isn't the only thing changing. We are entering the zone of extreme tidal forces. Here, gravity pulls much harder on Nova's feet than on her head, and things are about to get messy. This is where the nightmare truly begins. Because gravity pulls so much stronger on her feet than her head, Nova gets stretched out like a long noodle. Scientists call this terrifying process spaghettification, where she is pulled vertically and squeezed horizontally until she becomes a stream of atoms. We've crossed the invisible line, the event horizon. Inside here, the rules of reality flip completely. Space and time actually swap roles. The center isn't just a direction anymore. It becomes a moment in time, as inevitable as tomorrow. We have arrived at the ultimate destination, the singularity. This is a point of infinite density where space and time are crushed into zero volume. Here, the laws of physics as we know them completely break down, and reality itself shatters. We've survived the event horizon, endured the nightmare of spaghettification, and faced the impossible singularity. But the biggest question remains, is Nova's information lost forever in the abyss? Or is it preserved on the surface? Tell us your theory in the comments below.
Imagine an engineer who redesigned Tokyo's entire subway system. Now imagine they have no degree, no eyes, and literally no brain. Meet the world's smartest blob. Meet Physarum polycephalum. It looks like someone spilled mustard on a log, but it's not a plant or animal. This entire yellow blob is actually just one single giant cell, containing millions of nuclei. It doesn't walk. It flows like a pulsating smoothie. While it hunts bacteria in the wild, in the lab it goes absolutely crazy for simple oat flakes. Yes, this genius runs on breakfast food. Scientists put this blob in a maze with food at the exit. It didn't just find the way out. It retracted from every dead end to form the single, shortest mathematical path. It literally calculated the perfect shortcut. To test its limits, scientists built a tiny Tokyo inside a Petri dish. They placed oat flakes exactly where major train stations belong. 37 tasty stops for one very hungry commuter. After just 26 hours, the blob finished its masterpiece. When overlaid on the real Tokyo map, the networks were nearly identical. It essentially redesigned decades of complex human engineering in a single day, just to get to lunch faster. It runs on a simple rule: use it or lose it. Tubes with heavy nutrient flow get wider, while unused paths shrink away. It's a biological computer processing lunch instead of data. So, You don't need a brain to be a genius. Just a really good appetite. Nature, 1. Humans, 0. Maybe we should let the slime run the trains. Meet Lake Natron, nature's real-life Medusa. It's blood red, and rumour has it, one dip turns you into a stone statue. Talk about being fully petrified of a swim. Relax, it's not instant magic. One touch won't turn you to granite immediately. Instead, think of it as nature's creepiest pickle jar, a super salty mummification vat that preserves bodies perfectly over time. Think of it as the ultimate ancient Egyptian spa treatment. The water is packed with soda and salt that sucks out all the moisture. This stops decay bacteria cold, preserving the body just like a salty mummy. So, where do these chemicals come from? Meet the neighbour, Oldoño Lengai. It's the only volcano on Earth spewing weird, salty lava that washes rare minerals straight into our lake. The result? A chemical nightmare. With a pH hitting 12, this isn't water. It's basically liquid ammonia. A quick dip here equals nasty chemical burns, not a refreshing swim. But why does it look like a giant pool of tomato soup? It's not blood, but billions of tiny cyanobacteria. These salt-loving microbes produce red pigment to photosynthesize, painting the entire lake in shades of deep crimson. You'd think this place is empty, right? Wrong. It's actually a high-security nursery for millions of flamingos. They treat this deadly caustic soup like a VIP fortress to keep hungry predators out. It's the ultimate defense hack. The burning water acts like a lethal moat, keeping hungry predators away. Flamingos evolved super tough, leathery legs to withstand the burn, turning this acid bath into the safest nursery on Earth. From stone statues to pink feathers. Lake Natron is nature's wildest paradox. It kills with chemistry, but protects life with a burning moat. Who knew a chemical bath could be this beautiful? Wait, hold up. Did you know a single bolt of lightning is actually hotter than the surface of the sun? It sounds totally insane. But get ready, because we're about to spark a serious heat battle. Check the power levels! The sun's surface is chilling at a mere 5,500 degrees Celsius. But lightning? It smashes the scale at a scorching 28,000 degrees. That's 5 times hotter in the blink of an eye.
Hold your horses.
To be fair to our big, fiery friend, we're only fighting the sun's surface, not its super hot core. That would be a total mismatch. It's like trying to shove a massive crowd through a single tiny door. Lightning forces huge amounts of electricity into a super thin channel of air. The air fights back with resistance, and that struggle turns into pure, blazing heat instantly. The air literally snaps under the pressure. That resistance creates so much heat that the gas molecules get ripped apart instantly. Boom! We're talking superheated plasma in a microsecond. It's basically a baby star exploding right in our atmosphere. Think of it like a laser versus a giant bonfire. Lightning crams all that crazy energy into a tiny space for just a split second. Total concentration. The sun is way bigger, but it spreads its heat out like a massive, steady radiator. One is a focused punch. The other is a warm hug. So, the underdog takes the crown. Lightning is officially the hottest sprinter, beating the sun's surface temperature by a mile. But hey, if you could bottle up all that zap in a battery, what's the first thing you'd power up? A giant robot? A laser sword? Tell me your wildest ideas below. Your physics teacher probably promised that you can't create matter out of thin air, right? Well, quantum physics explicitly declined that memo. Let's explore the Schwinger effect, where we can literally rip the universe apart to make something out of absolutely nothing. You probably think empty space is just empty. But quantum physics says that's a total lie. The vacuum is actually a chaotic, bubbling soup of virtual particles popping in and out of existence faster than you can blink. It's basically a cosmic bank loan scam. These particles borrow energy to pop into existence. But the deal is, they have to crash back together and repay the debt immediately before the universe realizes the cash is missing. But here is the plot twist. Julian Schwinger realized you can act like a cosmic homewrecker. If you blast that space with a powerful enough electric field, you can grab those particle twins and physically rip them apart before they have a chance to disappear again. Here is the payoff. The electric field literally pays the universe's energy bill, so the debt is settled. Suddenly, those ghostly borrowers stop being virtual and solidify into real, permanent matter. Congratulations, you just squeezed actual physical stuff out of empty space. So why aren't we printing free matter from thin air yet? Because the energy bill is literally astronomical. Reaching the Schwinger limit requires an electric field billions of times stronger than the most powerful lasers on Earth. It is basically like trying to boil an entire ocean with a single matchstick. But humans love a good shortcut. Scientists found a literal cheat code using graphene, a supermaterial just one atom thick. Inside this carbon honeycomb, electrons behave like they have zero mass, which lowers the energy barrier enough for us to simulate the effect without needing a laser the size of the sun. This effect bridges the gap between ghost energy and solid reality, likely explaining how the Big Bang filled our empty universe with actual stuff. So yes, you technically can make something from nothing. You just need an electric bill larger than the sun. Ever wonder what happens if you keep zooming in on a simple apple? Past the skin, past the cells, way past the atoms. Join Akira as we dive deeper than any microscope can go to find the ultimate building block of the universe. So here's the drama. Physics basically has two rulebooks that absolutely refuse to get along. General relativity handles the heavyweights like stars and gravity, while quantum mechanics rules the chaotic, tiny world of atoms. They work fine apart, but try to introduce them to each other? The math completely breaks down and screams error. The standard model treats particles, like electrons, as boring zero-dimensional dots. But string theory completely flips the script. It suggests that if you look close enough, those dots are actually tiny, vibrating filaments of energy. Think of the universe like a giant electric guitar. Pluck a string one way, you get an A note. Pluck it differently, you get a C. These cosmic strings work the same way. An electron is just a string vibrating in one specific pattern, while a quark is the same string dancing to a totally different tune. Here's the catch, and it's a weird one. For this beautiful string math to actually work, our universe can't just have the 3 dimensions we see. Nope, the equations demand a universe with 10 or even 11 dimensions. Imagine trying to give someone directions in that world. So where are these extra dimensions hiding? Under the rug? Think of a garden hose viewed from far away. It looks like a boring, flat line. But zoom in, and a tiny ant can walk around the loop, discovering a hidden dimension. Physicists think our universe's extra dimensions are curled up exactly like that. Tiny loops of reality that are just too small for us giants to notice. Here is where it gets absolutely bonkers. Since those extra dimensions can fold up in trillions of different origami shapes, each shape creates a totally different rulebook for physics. That means our reality might just be one tiny bubble floating in a giant cosmic foam of universes, where the bubble next door has gravity that falls up. So, is this whole cosmic symphony actually real? Well, awkward pause. We honestly can't prove it yet, because these strings are way too tiny to see. But even if it's just fancy math for now, it's pretty incredible to think our universe might not be made of hard rocks, but of pure, vibrating music. Imagine a creature that dresses like a disco ball, but fights like a heavyweight champion on steroids. This is the peacock mantis shrimp, and while it looks like a harmless party favour, it has earned the terrifying nickname Thumb Splitter. Here's the twist. They aren't actually shrimp at all. They are stomatopods, ancient predators that split from the family tree 400 million years ago. Aquarium owners are actually terrified of them, because this 4-inch creature can literally shatter a glass tank with its club-like arms. But here's the secret. Simple muscles are way too slow underwater. Instead, its arms work exactly like a loaded crossbow. It locks a biological latch, compresses a spring-like saddle to store massive mechanical energy, and holds it under extreme tension until it's ready to snap. When that latch snaps, the club accelerates with the same force as a .22 caliber bullet leaving a gun barrel. If a human pitcher could throw a baseball with that kind of acceleration, the ball wouldn't just strike the catcher's mitt. It would literally launch into low Earth orbit. But wait, it gets completely unfair. That strike is so fast, it rips the water apart, creating a vacuum bubble through supercavitation. When that bubble collapses, it unleashes a shockwave that stuns prey even if the punch misses. So he hits you twice. Once with the fist, and again with the explosion. The physics inside that collapsing bubble are absolutely apocalyptic. For a split second, the temperature spikes to 4,400 degrees Celsius, nearly as hot as the sun's surface. It even creates a flash of light called sonoluminescence. Yes, this shrimp punches so hard it literally boils the water and creates its own light show. You're probably wondering, hitting that hard should shatter the shrimp's own arm, right? Well, nature is a genius engineer. The club is built with layers of fibers stacked in a twisting spiral pattern called a bouligon structure. This acts as a shock absorber, stopping cracks from spreading through the shell. It's so effective that scientists are literally stealing this design to build better body armor for humans. If you think the punch is wild, wait until you look at their eyes. While humans are stuck with just 3 color receptors, the mantis shrimp rocks a staggering 16. They can see ultraviolet, polarized light, and colors we can't even comprehend. To them, our reality is a dull black and white movie, while they're living in an exploding psychedelic kaleidoscope. So it's a living rainbow, a supercomputer, and a heavyweight champion all rolled into one tiny package. The mantis shrimp is nature's ultimate engineer, proving that the ocean is full of beautiful, terrifying miracles. Next time you see the calm blue sea, just remember, down there, a colourful gladiator is literally punching the water until it boils. Ever notice how the universe is totally obsessed with balls? I mean, you never look up and see a giant space pyramid or a cube-shaped star just chilling in the galaxy. It turns out gravity is basically the ultimate control freak. When a planet is born from a messy cloud of space dust, gravity yanks everything toward the center with the exact same force from every single direction, refusing to play favorites. Think of gravity like a bunch of screaming fans trying to get a selfie with a massive pop star. Everyone pushes toward the middle to get as close as possible, naturally forming a tight circle around the celebrity. It's not a square or a triangle. It's a circle, because that's the only way everyone gets an equal shot at the center. Once a planet gets massive enough, gravity stops asking nicely and starts crushing. The pressure becomes so intense that solid stone effectively gives up and behaves like a liquid, flowing to smooth out all the jagged bumps. We call this hydrostatic equilibrium, which is basically just a fancy way of saying gravity is hugging the planet into a perfect shape. But here's the thing. Gravity is totally lazy if you're small. Tiny asteroids and moons don't have enough mass to crush their solid rock into a sphere, so they stay jagged and lumpy forever, literally drifting through the cosmos like giant, ugly space potatoes. But here's the plot twist. Even the big planets aren't perfect spheres. Because they spin so fast, they actually get a bit of a muffin top around the middle. This centrifugal force pushes material outward at the equator, turning them into oblate spheroids, which is basically science speak for a ball that someone sat on. So, gravity is basically the universe's perfectionist artist. It lets the tiny space potatoes stay messy, but for anything massive, it smooths out the rough edges until it creates a round masterpiece. Just remember, in space, being well-rounded isn't just a personality trait. It's the law. Ever notice how Earth loves a dramatic wardrobe change? 1 minute, it's beach weather. The next, we're freezing. But then there's Jupiter, the solar system's stubborn giant, who literally refuses to tilt, stuck in the exact same extreme forecast for billions of years. So here's the deal with Earth. We're basically the slouchers of the solar system. We lean back at a cool 23.5-degree angle, which is exactly why we get to swap swimsuits for snow coats, depending on which side is hogging the sunlight. But Jupiter? Oh, he's the strict drill sergeant of the solar system who refuses to relax. With a tiny tilt of just over 3 degrees, this giant stands practically vertical relative to the sun, refusing to lean even a little bit. Because he stands so stiff, the sun hits the exact same spots every single day. Imagine the sun staring directly at your forehead for 12 years straight, without blinking. That is basically just a Tuesday on Jupiter. Since there are no seasons to shake things up or change the temperature, the weather just never knows when to quit. This permanent setup lets monsters like the Great Red Spot rage on for centuries without ever taking a lunch break, while poor Uranus got totally knocked on its side by some cosmic bullies ages ago. Jupiter was just way too big to budge. Thanks to his massive gravity, he basically shrugged off the kind of collisions that toppled everyone else, staying upright like a cosmic sumo wrestler. So next time you're tired of winter, just remember, Jupiter has been stuck in the exact same bad weather since the dinosaurs. Personally, I think I'll stick with Earth. Permanent hurricane season is just way too much drama for one planet.
We're doing the impossible, flying a spaceship straight into the sun's corona.
It's millions of degrees out there, enough to vaporize anything. Yet our probe survives. How does it not turn into a puddle of molten metal?
Let's dive in. Here's the mind-blowing part.
The sun's surface is hot, but the atmosphere around it? It's actually millions of degrees. That's vastly hotter than the surface itself. Logic says our probe should vaporize instantly in that kind of inferno. So what's saving it? Here's the secret. Temperature just measures how fast particles are moving. And out there, they are zooming. But heat, that depends on how many particles actually hit you. The corona is basically empty space, so there's almost nothing to touch the ship. Think of it like sailing a ship through a ghost ocean. The water molecules are moving at light speed, but there's only one drop every few miles. Since almost nothing actually hits the hull, that millions of degrees heat just can't get in. It's the ultimate magic trick of physics. So, if the plasma is too thin to burn us, we're totally safe, right? Wrong. There is a much deadlier enemy waiting for us. It's not the heat touching the ship. It's the blinding light itself.
Meet the thermal protection system.
It's a high-tech barrier coated in special white ceramic that acts like a cosmic mirror. It bounces over 99% of that deadly sunlight right back into space, stopping the heat before it even touches the ship.
This shield is an absolute beast.
The front side is roasting at 2,500 degrees, hot enough to melt steel. But just 4 inches behind it, it's a comfortable 85 degrees. Our instruments are literally chilling at room temperature, while facing an inferno. So, we survived the sun thanks to a lucky loophole in physics and one incredible shield. It's the ultimate victory of engineering over nature's fiery wrath. Now that we've touched the stars, I have to ask, where in the universe should we send a probe next?